In today's video, we're going to look at how AutoQuery can help turn a static dataset into a web API with minimal effort by using an Xkcd comic dataset as an example, and how this increased accessibility enables further reuse in various ways. A problem that many companies still face is data commonly starts off siloed in static datasets that's hard to share and reuse with others. Well-defined web services help solve this problem by unsiloing the data by making it more accessible and creating efficient access points, reducing the time it takes to get data from an experiment into a production application. Using AutoQuery to do this makes it fast, as it can generate those services directly based off the data itself, enabling simple querying, filtering, and sorting automatically. As a fun example, we'll use AutoQuery to create an API from a dataset of Xkcd comics that we can search and use in different ways. The dataset contains metadata of 2,630 comics, including fields such as title, transcript, explanation, and URLs pointing to different data sources, including the original comic URL itself. In this video, we will create an AutoQuery API to host our data, enabling us to easily filter, sort, and query our data in different formats. And then we will create a separate static site that will use the API to search for Xkcd comics, presenting them in a simple grid. Jumping into the example, let's first create our project for our AutoQuery API. Using the service-stack.NET tool, we can use the command xnew web myapi to create a project using the web template. The web template is the basic service stack template for building APIs, so we will also need to add support for AutoQuery and SQLite. We can do this by using the commands xmix AutoQuery SQLite to mix in these features to our project. This will create the configure.autoquery.cs and configure.db.cs file to set up the use of AutoQuery and SQLite. Next, let's grab the dataset itself, which is available on a repository on huggingface.co. The link's in the description. The dataset doesn't contain any of the actual comics, just metadata about them. So we'll need to load this data into our application if we want AutoQuery to use it. Let's create configure.db.xkcd.cs to isolate the logic of loading the data. We will also need a class to represent each comic metadata. Let's call this Xkcd comic, and it will have the matching properties related to each of the columns in the dataset. The dataset file itself is in a JSON-L format, meaning that it has a JSON object per line in the file. So we need to read each line and deserialize that object into our Xkcd comic type. Now the data is loaded into memory, we can use AutoQuery in a few different ways to expose the data as an API. However, in this demo, we're going to use SQLite as a data store, so we can use the default AutoQuery feature plugin directly with our SQLite database. And lastly, to create our AutoQuery endpoint, we need to create a request DTO like any other service stack service. Depending on the AutoQuery plugin you use, you will need to use the matching base class for your request DTO. Here we are using QueryDB as our base class, since our AutoQuery feature plugin is configured with our SQLite database connection. Running our application and navigating to the API Explorer application, we can see our query Xkcd comics endpoint, and we can also test our API using the provided form. We can also use the Service Stack low-code application with AutoQuery endpoints to better explore the data with built-in filtering, sorting, and querying support common to all AutoQuery services. Our data is now available in many formats and fully queryable with the built-in functionality of AutoQuery, which also has support for common database providers like Postgres, MySQL, and MS SQL Server as well. You could now integrate this API as a data source for Microsoft Excel for product managers, as an endpoint for use in Jupyter notebooks, or build your own custom web application, all using the same well-defined API. We've pushed this project to GitHub as a part of a common API backend for some examples. So here we see our endpoint hosted at ssg-examples.netcore.io. We've also enabled cores on this project so we can use it in separate examples. Now let's look at one of the ways you might do that by building a simple search and view interface for our comic data straight from our hosted API. To build this separate application, we're going to again use the serverstack.net X tool, but this time with a different template. Using the command xnew space Razor SSG space Xkcd, we will create a project that uses .NET Razor and Vue.js to create a static site we can deploy directly on GitHub pages. Opening our new Xkcd project, let's create a Vue component that lets us view the data from the API quickly in a data grid. Creating a new Razor page in the pages directory called xkcdcomics.cshtml, we can have our basic Razor page and a Vue.js component inline on the page. Our component will have the logic to fetch the comic data using our hosted AutoQuery API. However, since by default this template assumes you're developing against a locally running API, we will need to update our client to point to our remote system. We can do this in the app.mjs file in the www.root mjs directory. At the bottom of the file in the init method, we can specify a base URL to the JSON API client.create method call, which will mean the client injected into our other components will also point to our hosted API. We will also need to change the base URL configured in the dtos.mjs file to our hosted API address. This will ensure that our tooling knows how to keep our request and response DTOs in sync. This file does not yet have the query xkcd comics request DTO that we need, but since we just changed the base URL, we can run the command x space mjs and it will pull down the required DTOs, updating the dtos.mjs file. Going back to our Vue component and our data grid, we can now initialize the component by calling our remote API when it's initially mounted to fetch some data. We can use the take argument on the request DTO to limit the results that we receive to just 10 comics rather than the default 1000. And once this is updated, here is our grid loading our data and presenting it in a data grid. There's nothing much to see here at the moment since this is all metadata and URLs, but let's change a couple of templates in the data grid component so we can visually see each comic, and use the select columns and header titles properties to improve the presentation of the data grid. Reloading our page, and we can see our data is now rendering the comic since we have specified the image URL in an image tag in our data grid template. Another powerful component in the ServerStack Vue library is the AutoQuery grid component. This will automatically fetch our data based on the type attribute you provide on the component. Here we're specifying the Xkcd comic type, which is the name of our database model and the one our query Xkcd comic request DTO is using with the base class QueryDB. If we look in the JavaScript code in the Vue component, we now only have logic for selecting a row on the grid. Everything else is taken care of with the AutoQuery grid component, and this also extends to create, update, and delete commands, enabling you to manage your data all through this component with minimal code. The AutoQuery grid component can do this by utilizing the service metadata information about the services you are using, in this case the hosted Xkcd service. This does require loading the app.json metadata from the hosted services, which we can add in the app.mjs file in the init method using the updated base path from earlier. Taking this further, we can use our own custom grid HTML to preview each comic with a title, and by clicking on it, we can view a larger version with an explanation in a modal dialog. The modal dialog is also built into the ServerStack Vue library, and we can use this in combination with a simple search input to further improve the use of our dataset. The search term will then be passed to our request DTO by using the title contains property. Title being the column in our dataset and contains being a suffix AutoQuery understands, the API will return us a filtered set of results where each comic title contains our search term. This enables a simple but effective search as you type experience for your favorite Xkcd comic, where you can read the explanation or click through to the original website. Pushing our repository to GitHub allows us to quickly deploy the site using GitHub Pages, and a live demo is also available, link in the description. If you want more information on this template, check out our other videos on Razor SSG. Making data more accessible can lead to product improvements much more quickly, and making that process straightforward and easy to do using AutoQuery means you can benefit from that improved data accessibility sooner rather than later. AutoQuery also supports generated services straight from your SQL schema, migration to code first, full create, read, update and delete solutions, and many more built-in UIs and features to help you unsilo your data faster. Well, that's it for this video. If you have any suggestions or feedback about our templates or videos, let us know in the comments. If you want to know more, check out our other videos and join us in the ServerStack community through our Discord and GitHub discussions. ServerStack is free for individuals and open source projects, so anyone is welcome. And as always, thanks for watching.